Okay, we're going to look at graphing linear equations and the table method, and let's just try it. Now, these questions here, we've actually already graphed them in the first exercises. They're functions, because for every x value we put in, we only get one value out for y. That's what makes it a function. You put in one value for x, you get one thing out for y. But there were all these points, I think 7 or 8 points. You only need 2 points to graph a line. You only need 2 points. And they're called linear functions because they make a straight line when you graph them. Now the question is, how do we choose? And people always ask me, how do you know what numbers do you put in for x? Well, one thing is, putting in 0 is a good idea because it's usually really simple. In 3 of these questions, if you put in 0, 2 times 0 is 0 plus 3 is 3. So 0 and 3 is a point. That's a very easy point because when we graph it, it's right on the white line on the y line, which is called the y-axis. If we put in 0 here, we get minus 3. If we put in 0 here, we get 5. If we put in 0 here, we get a fraction. So maybe it's not such a good idea. Now, if you just pick small numbers on either side, you could pick 156, but it's really hard to graph. Just pick the next number over, like 1. 2 times 1 plus 3 is 5. 2 times minus 1 plus 3 is 3 minus 2. That's 1. These are very small numbers, and they're easy to graph. I picked small numbers, put them in here, and got a y value here. The choices I made here were a little bit different. See, if I chose minus 2 plus 2, I get 0 divided by 3 is 0. Now that's actually an x-intercept where y is 0. But if I put in 1 plus 2, that gives me 3. I want multiples of 3, so when I divide by 3, I get a nice even number, like 4 plus 2. 6 is a multiple of 3. 6 divided by 3 is 2. Look at these nice even points. Now I'm going to look at these 3 graphs and just how we go about graphing them. So like I said, we choose 0 and 3. We put in 1. 2 times 1 plus 3 is 5. And like I just said, 2 times minus 1 plus 3 is 1. Now all we do is we go and we graph these points. 0 in the x direction and 3 in the y direction. There it is. And then 1 in the x direction and 5 in the y direction. Minus 1 in the x direction and 1 in the y direction. So when we let x equal 0, y equals 3 is called the y-intercept. It's called the y-intercept of the line. And the coordinates are 0 in the x and 3 in the y. These arrows on the end of the line mean it goes on forever. And there's something, we connect the line and we make it solid. That's because even between 0 and 1 here, there's actually an infinity of points between this 0 here and this 1 and 5. There's an infinite amount of points. Imagine you could put in 1 over 10, 2 over 10, 3 over 10, or 1 over 100 and then get an answer. It would make this thing solid, or 1 over 1,000,000 even, and put it in and get another answer up here. So anyways, that's why it's a solid line. Let's look at question B here. So we put in 0 and we got minus 1. There it is. I cheated and got a computer to graph it really nice. If you put in 1, 3 times 1 minus 1 is 2. 1 and 2 is a point. And 2 and 5, you get the same way. You just graph them. Hey, there's something to notice. This line, y equals 2x plus 3, the last one we did. Let's look back here. It's a little bit flatter. This one's going more straight up and down. So when the number gets bigger, we call it the gradient. So 3, the gradient is steeper, or in Canada, the slope is steeper. It's steeper. Going from left to right, it's going uphill. Notice that 3 is greater than 2. That's a big thing. We let x equal 0. That's how we get the y-intercept. Let's look at this last question. Hey, minus 3x plus 5. Look at this line. It's going down. If we put in 0, we get 5. But if we put in 1, minus 3 plus 5 is 2. 1 and 2. Well, we connect those 2 points, it goes down like that. Put in 2. 5 minus 6 is minus 1. 2 and minus 1 is a point. Hey, the number in front here is negative. Whenever that happens, the line will go downhill. we say that the gradient is negative. The gradient is negative, and it's all about this number in front of x here. Well, that's how you graph. I'm going to give you a whole bunch of questions to graph, just like the 3 that we've done. And I want you to use this idea. Always look for x equals 0, and then get what? You can make a little table like this, but choose x equals 0 most of the time. It's a good idea.